Einer dieser Computerwissenschaftler ist heute unter uns ist Siavash, Ghiasvand vom ZIH. Hallo Siavash. And now we will learn something about, conquering the world or something like that. Much fun with Siavash, Ghiasvand.
Don't worry. So, hello. Today I'm going to talk about divide and conquer. But don't worry, usually you hear that phrase in military activities. But here we are going to talk about something else, which is computers. This one, yeah. So parallel computing, supercomputing, or whatever other names which is related to that. All of us know this famous story. Once upon a time there was a man who had 3 kids. Once he called all of them, gave them a bundle of sticks, and asked them to break that piece of stick, but none of them could do that. Then he split the sticks and gave each of them 1 piece of sticks, and they could easily break them. Then he gathered the sons and conclude that when you are together, you are stronger, in a Polish way. And we learned that. We all know how it works. In the daily life, well, that's not a daily life example, but in a daily life, we know how to do teamwork, and sometimes we are actually overdoing that. But we are not alone. There are other creators who know how to use teamwork. And sometimes we are even making a team of teams to do that. And like any other concept, it might be some misunderstandings of the concept. Especially that guy. Now let's be a bit more scientific. We have a problem, and we want to solve that problem. Solve. Sometimes the problem is too big to be solved by that solution. In these cases, usually we need help. After you have proper helps, you can solve the problem easily. Computers are our friend for a few decades, almost 100 years. Computers are like human. They can also bring their friends when you give them a big problem. This is what it looks like. But we know that humans used to reduce the size of everything except themselves. Computers are not exception again. So this is how we make them smaller, and then we call them something else. We'll start with a normal computer. We dismantle the computer. We would put all the non-green stuff out. Then we will keep all the vital parts. We put everything in a new case, new clothes. Then we will put them in a rack. This is what you see. And then we will make thousands of them. This is how it looks at the end. And if we just step back a bit, this is the final shape. This is what we call a supercomputer. So all of them, friends together, delicious. Now what we do with this? Imagine if you are being together, you will be stronger. So what is the opposite side? When you are getting divided, you will be weaker. So this is what should we do with the problem. For us, we should get together and be stronger, and for the problem, we should divide them, so then it will be weaker. We are using that. Do you remember that very scientific example? There was a problem, there was a solution. The solution, united, get stronger, then we can also divide the problem. So it's easier, at least your dress will remain neat. So this is what should we do with the normal problems too, in the normal life. Now please, one people solve this equation for me. I'm waiting. Okay, let's do something else. First a bit of warm-up. But for the warm-up part, we need some group of people. Everyone, not everyone, but some people on the first row receive some papers. On each paper there is a color name. Everyone who is sitting behind that person are in the same group. So everyone who got the paper, could you please just bring it up? Yeah, and could you please rotate so everyone can see that? I can see this is green, that's red, violet probably, yeah, gray, pink, brown, blue, yellow. So everyone who is sitting behind of that paper, you are in the same group. Now, a bit of warm up. Thank you. So everyone now know their group, okay? Once you saw an equation in your color, please reply immediately. Okay? Don't laugh, reply. Just tell. Ah. Perfect. Verlan. Oh, it gets complex. Both. Perfect. Well done. Again, I needed to do it a bit faster, okay? Ready? Once you saw the color, please tell. Perfect? Done. Now we are going to a real example. So please, based on your color, solve this. Well, solve this one. In few seconds, each of these blocks will be filled by one of these equations. Once you saw your equation, please immediately reply. Okay? Ready? Set? Here we go. Perfect. Again, just because to be constant again. Ready, set, go. Thank you. Now we are going for the next round. Ready? Done. And finally, 6, exactly. Perfect. It just took few seconds for us all together. So what we did was simple. We just divided the equation among the people, and after we divided, each of us take responsibility of one part of the whole sequences of equations. And then we easily, based on that color, could divide and conquer. We did it. Well, now let's back to the computer. This is exactly what happened in your code. When you're writing a code, I don't know if you did it or not, but it's very easy. The concept is very easy. Usually we are using computers to redoing some stuff, which is boring for us. If we want to do something once, we never write a program for that. We are writing a program when we want to something be repeated. So this is a very easy question. What is going? It's a piece of code written in BASIC, probably the former type of what you know at the moment as .NET framework. So it doesn't matter. It says count from 1 to 10, and each time print the multiply of whatever number that you have with itself. So it means that 1 multiplied by 1, 1, 2 multiplied by 2, 4, and so on. This is the old way. So it says, okay, 1 multiplied by 1, 1, and then 2 by 2, 4, and then 3 by 3, and so on, and so on. This is exactly what happens in a normal situation. So, but what we do is changing this boring situation to something a bit fancier. It means that we all get involved, and this is what happens. All of us take a piece of the code, we do it in one step. This is the divide and conquer. This is behind all the applications that you see. Everything that you see at the moment, doesn't matter how fancy it is. Behind the scene, we are doing that to make it faster. Then we will feed that to that supercomputer which you just saw, or this kind of human supercomputer which we just made. Just to give you an example about how advanced this method can go, take a look at this picture. This is how we are growing the performance. In 1995, we used to be here. Now in 2015, we are here. On the brown triangles here, on the last one, it shows how many equations can we do in only 1 second. First of all, I should tell you how many people are participating, in this case, CPUs, computers. That's the number. So 3 million computers are working together, and the power that they can that they have at the moment, and the number of equations that they can solve in only 1 second is this number. Starting. Oh, it's not enough? Oh, it's there, yeah. That's the number. Interesting, no? Okay, now in this picture we just saw at the first, which one is the supercomputer? Nah. The small one. Thank you for your attention.